Okay, explain why a filament lamp appears brighter and less red as its temperature increases. Now we've been given this diagram to work with, okay? It's the intensity versus a wavelength for a filament lamp. And we've got to extract 4 marks out of this. Okay, so it's another one of those dull, dry, standard exam questions where you've got to use exam technique to say the obvious. Say things that you think, well, that's just obvious. That's not really part of the question. Trust me, say the obvious and you'll probably get a mark for it. Do it in a logical order, and that's exam technique. That's how you extract the most number of marks for questions like this. So, say something like this for this question. Okay. Right, explain why a filament lamp appears brighter and less red as its temperature increases. Right, say the obvious. Firstly, at higher temperatures, the intensity is greater than at lower temperatures for all wavelengths. Okay? It's obvious. You're just looking at the information I've given you and stating something obvious from that information. Okay? So I'm going to have to try and do this shorthand. I can't write out the whole thing, it would be here forever. So the first thing, at higher temperatures, the intensity is greater at all wavelengths. Okay? 1 mark. Right. Next. Say something else that's maybe in this case not quite so obvious, but if you think about it, I'm sure we can come up with it. As you go from low temperature to high temperature, the distribution of wavelengths changes. That's just a clever scientific way of saying that the shape of these two lines is different at the different temperatures. The peak is in a different place, for example. So, as you go from low to high temperature, the distribution of wavelengths, lambda. Lambda means wavelength. You knew that, right? Distribution of wavelengths changes. Okay? Just stating the obvious. Okay? Never be afraid of stating the obvious. Okay, next. Just exam technique. Right. So, state something else that's obvious. The peak at the low temperature is around 800 nanometers. Okay? Okay, you might not get a mark for saying every obvious thing, but the more you list, the more likely you are to get marks. So, at low temperature, the peak is around 800 nanometers. Okay? Right. Now you can show off a bit of your knowledge. Also, in these questions, let the examiner know what you know. Show off slightly, okay? This is an opportunity to let the examiner know that you know human visible range. Okay, I didn't write this, but they actually told you that 390 to 700 nanometers is the human visible range. Okay, they did give you that on the question paper, but you can tell the examiner that you know from about 550 to 700 nanometers is the red range. We see that as red. Okay, so here's an opportunity. Right. So, at low temperature, the peak is around 800. This is outside the human visible range, but it gives the low temperature curve greater intensities in the sort of red region, the 550 to 700 nanometer range. Okay? Therefore, at low temperatures it appears more red. That's it. Right, so how am I going to summarize this quickly? Low temperature, the peak's 800, outside human range, but greater intensities in the 550 to 700 red region. Therefore, it's more red. Okay? You getting the idea of how to do these sort of questions? Right, so we're well on our way to 4 marks. Okay? Right, exactly the same thing at higher temperature here. So, at high temperature, at high T, the peak is around 500 nanometers, yeah? Okay, stating the obvious. So, again, show off your knowledge. You know that from about 390 to around 500, 550 is the blue region. So this is the blue light region. So we're just repeating exactly what we said here, but same reasoning, but just for blue light. So greatest intensity in the blue region, therefore it appears more blue at higher temperature. More red at lower temperature here, more blue at higher temperature, more blue or less red. And that's it. That will get you the 4 marks. Okay, good. Right, next question. Let's change colour. Right, we have a Geiger-Müller tube. They tell us that the count rate, okay, I'm just going to write it as CR. The count rate is K over D squared. They also tell us that when D is 0.70 meters, then the count rate, CR, is 8,500 per minute. And we have to find the count rate when D equals 1.3 meters. Okay, well, that's everything I think. Yep, that's it. Okay, this, where should I stand? Ah, screw it. This is just a maths question, okay? It's a constant proportionality maths question. So go and look at my maths videos if you want to know a bit more about this and revise. Constant of proportionality stuff. So, pretty straightforward. First thing to do is find out what K is. CR equals K over D squared, rearrange that, therefore K equals, multiply both sides by D squared, K is CR times D squared. Simple. Therefore, K equals, now we use the numbers they gave us. CR is 8,500? 85,000, obviously, okay, 85,000. CR times D squared, 0.7 squared, okay? That's it. Because when D is 0.7, count rate is 85,000. Now, I could grab the calculator at this point and work out exactly what K is. But why do 2 calculations when 1 is sufficient? We'll include that in the final calculation at the end, so just leave it like that, okay? Now, we have to find the CR when D is 1.3. So, therefore, well actually, technically, well, I could leave therefore there, but I'm not going to. Okay, we're going to go back to this equation now. CR equals K over D squared, which equals K is that 85,000 times 0.7 squared all over D squared, and we want CR when D is 1.3, so 1.3 squared. Now we're ready. Stick that in your calculator, single calculation, and we get the answer. So CR is, stick that in the calculator, and it turns out to be 24644.97041. We're not going to leave it like that. Let's take it to 5 decimal places. It's a reasonable choice, which is 246, that 9 pushes this 4 to a 5, so it's 2464525 dp. Okay? Straightforward maths question. Good. Right. I'm going to clean the board. Right. Final question of this miserable question. Miserable because it's just so dry and exam technique-y. Now we've got a 6-mark question. Oh God. Agony. Okay, let's get through this. Sulfates and soot are formed by industrial processes. Some of these are found in the atmosphere over the Arctic Ocean. Sulfates stay in the atmosphere and scatter sunlight. Soot falls onto the Arctic ice. Discuss how a reduction in these industrial processes is likely to affect the temperature of the atmosphere. 6 marks. Okay. Right. So it's the same thing again. Say what you think might be fairly obvious. Use your knowledge. Lay it out in a nice ordered fashion. Okay? So, they tell us that sulfates scatter sunlight. Okay, so where should I do this? Okay, so the sulfates scatter sunlight, right? And sunlight contains infrared radiation. That's the important bit. You've got to let the examiner know that it's not just light. Infrared light is the relevant one here because infrared light is the wavelengths that heat up the atmosphere. Okay. So sulfates scatter light. Light contains IR. So therefore IR is, some of it is being reflected back into space. Okay? So, yeah, don't forget, I said it, I'm just going to write it down. IR warms the atmosphere. Okay? Just get the knowledge down and you'll get the marks. See, look, that's a good example, okay? I was kind of guilty of that myself, not saying the obvious. It feels obvious that IR is the part of the spectrum that heats the atmosphere, okay? But you've got to remember to write it down and say that, get it on the paper. Say the obvious, that the infrared warms the atmosphere. Okay. It's easily done to not write the obvious. Okay, so therefore, a reduction in industry will lead to reduction in sulfates. This is just the logical sequence of events that you've got to write. Reduction in industry leads to a reduction in sulfates, so less scattering. And you've got to write full sentences, okay? I'm doing this because we'd be here forever if I wrote the full sentences. Okay. So, leads to maybe an increase in IR warming. This is only sulfates though, due to sulfates. We haven't talked about soot yet. We'll do that now. Okay, so that's sulfates dealt with. Right, same thing with soot. Okay, soot is black, and black objects are good at absorbing infrared radiation. Okay, use your knowledge. Tell the examiner what you know. Okay, then say the obvious. Therefore, this will lead to an increase in the temperature of the ice, because the soot is on the ice. Okay, so therefore, reduction, same thing, industry, will lead to less soot, therefore less IR absorption, and therefore less warming or lower temperatures of the ice due to soot. Okay? Good, so we're well on the way to 6 marks. Okay, let's just finish it off, round everything up because it's a mini essay, and say something like they have opposite effects. Okay, so soot and sulfates, opposite effects on, it's an E, on the temperature, and it's not clear which has the greater effect. So therefore, a reduction in industry may or may not lead to a reduction in atmospheric temperatures. Okay, finished. Right, so that's it. That's how to approach these sort of agonizing mini essay 6 markers. Okay, to get down on the paper the obvious. IR warms atmosphere. Okay, soot is black. Then use your knowledge. Black things are good at absorbing IR. And then write things out in an obvious, make it obvious. It's almost like you're treating the examiner like a 6-year-old. You have to explain it really clearly, okay? A reduction in industry leads to a reduction in sulfates, therefore a reduction in scattering, therefore the infrared warming will increase because there's less scattering due to sulfates. Okay, and that should get you the 6 marks. Good luck.